Today in Algebra 2, we're going to be looking at some of the characteristics of quadratic functions. What we will learn today is how to find the axis of symmetry and the vertex of quadratic functions, and how to find the maximum and minimum values of the quadratic functions. We're going to start with an example of a quadratic function written in vertex form, and we want to graph f of x equals -2 quantity x plus 3 squared plus 4. We want to label both the vertex and the axis of symmetry. So to start with our graph of this, we have looked at graphs of this type of function before as transformations of y equals x squared. At this point, we're actually going to look at the graph of this by first identifying the axis of symmetry and the vertex. So starting with our axis of symmetry, we've learned that our axis of symmetry comes from the number that is added or subtracted to the x within the parentheses that's going to be squared. We looked at the form as y equals a, quantity x minus h squared plus k. Our axis of symmetry, we learned, is x equals h. So in this problem that we have right here, we have x plus 3, which is the same as x minus -3. That is, our function can be written as f of x equals -2 quantity x minus -3 squared plus 4. Our h then is identified as -3, so our axis or line of symmetry is the vertical line x equals -3. The vertex we find by finding both h and k. The vertex is the ordered pair h, k. So we see that h is -3 and k is 4. Our vertex then is the ordered pair -3, 4. That's a good place to start for graphing our quadratic function. So let's put an x and y axis on our page here. And we can do that here. So our x-axis and our y-axis, going by a scale of 1, the point -3, 4, 1, 2, 3, 1, 2, is here. That's our vertex. We're going to label it with its coordinates, -3, 4. The axis of symmetry is x equals -3, and we're going to put this on the graph in the form of a dotted line so that we see where this axis is going. So here's our axis. Okay? Since our axis of symmetry, half of our points of our parabola will be to the left side and half of our points will be to the right side. So all we need now is 1 or 2 points on one side of the parabola and we will be able to get the graph. So let's choose a couple of points for x, and let's choose them near the axis of symmetry, -3. So let's choose x to be -2 and -1, because those 2 points are near our axis of symmetry, x equals -3. So we're going to substitute -2 and -1 in for x into our equation. So when we do that, we're substituting in here. Our -2 plus 3 is 1. 1 squared is 1 times -2 is -2 plus 4 is 2. And if we substitute in -1, we have -1 plus 3 is 2. 2 squared is 4 times -2 is -8 plus 4 is -4. So let's graph these points. We have the point -2, 2, and the point -1, -4. This is one side of our parabola, only one side of our parabola. To get the other side of our parabola, we simply reflect it over the line of symmetry. So our first point at -2, 2 reflects over to the point -4, 2. And our second point, -1, 4, is going to go 2 units to the other side of the axis of symmetry. And so we have the other side of our graph. Okay, so there we have our vertex, Our axis of symmetry is x equals -3. And notice that our vertex here is the highest point on the graph. So in this case, our vertex is a maximum. And we say that the maximum value of the function is going to be the highest point on the graph, or the highest y value on the graph. So the maximum value of this function is 4. Okay, let's go on now. Suppose that we have an equation, another parabola, another function, and it's in vertex form, but we would like to write it in standard form. Standard form is f of x equals ax squared plus bx plus c. So in order to get it into standard form, I'm going to have to multiply out this binomial, combine like terms, and simplify this function. So let's do that. We have f of x equals -2. When I square a quantity, it means to multiply it by itself. So that means x plus 3 is getting multiplied by itself. So let's go ahead then, and let's take these two binomials and let's multiply them together using the acronym that you've learned in the past, FOIL, first, outer, inner, last. There's a little bit of a shortcut when we're squaring binomials, but for our purposes, it's always easy to go through the steps and do FOIL. So we're going to do that. We have -2, and FOIL, f is first, so x times x, it's going to be our first term. O is outer and I is inner, so I'm going to do the outer is 3x, and the inner is another 3x, and the last is 9. And finish writing the function. Now I need to distribute actually before I distribute, let's combine some like terms inside this parentheses. So we have -2 x squared plus 6x plus 9, that quantity, and then plus 4 on the outside. Distributing the -2 gives us -2x squared minus 12x minus 18 plus 4. And finally, combining the like terms, we get -2x squared minus 12x minus 14. Here's our function f of x. It's in standard form. Our a is the coefficient of the x squared term, so our a value is -2. Our b is the coefficient of the linear term, so for b we're going to have -12. And our c is our constant term, -14. This is in standard form. Now, what can we do with equations of quadratic functions that are in standard form? Well, let's take a look at some core concepts of a parabola, the function of a quadratic written in standard form. So what are the properties of the graph of f of x equals ax squared plus bx plus c? First off, if this leading coefficient, if the value of a is greater than 0, the parabola is going to open upward. Okay? If the a is negative, the parabola is going to open downward. Okay? Next, our line of symmetry that goes up the middle of the parabola is found by using the terms b and a. The line of symmetry is x equals -b divided by 2 times a. Okay? Now, our steepness of the graph has to do with the absolute value of a. If our absolute value of a is greater than 1, numbers like 2, 2.5, 3, our graph is going to be steeper than y equals x squared. The same is true in opening down. If our a is like -2, -2.5, -3, it'll open down, but it will also be steeper than the graph of y equals x squared. Okay. Finally, to find our vertex, once I find the line of symmetry, I take that value for x, and I'm going to plug it into the vertex. A nice point to use to get the graph of the parabola is the y-intercept. Remember, the y-intercept is the coordinates of y when x is 0. So our y-intercept would be here at 0c, or at 0c. That's a lot of information. So let's go through an example and go through step by step. So let's start with our parabola, our function, g of x equals 3x squared minus 6x plus 1. This graph is going to open up because 3 is positive. Our leading coefficient, the coefficient of the x squared term, is positive because 3 is positive. Okay? This graph is also going to be steeper or narrower than the graph of f of x equals x squared because the absolute value of 3 is greater than 1. Okay. Our axis of symmetry then is found by using the rule x equals negative b divided by 2a. So I need to identify the a and the b. The a is 3. The b is negative 6. So using those in our rule for finding our line of symmetry or our axis of symmetry, we get x equals the opposite of negative 6, so positive 6, divided by 2 times 3. Order of operations, we're going to do this 2 times 3 first and then the division. So I have 6 divided by 6, or 1. So our axis of symmetry is the vertical line x equals 1. It's not a number, it's a line. So it's x equals 1. To find the vertex, I'm going to use 1 in for x in my function and find my function value. So I'm going to take g of 1 equals 3 times 1 squared minus 6 times 1 plus 1. Simplifying, we get g of 1 equals 3 minus 6 plus 1, or g of 1 equals negative 2. So our vertex is the ordered pair 1, negative 2. Now, since this graph opens up because the 3 is positive, this point right here, if we're thinking about it opening up, is going to be the lowest point on this graph. So this point is going to be a minimum value. Let's look at that. So it's going to be a minimum value, and the y-coordinate of the vertex, which is the minimum value, is negative 2. So we're going to have a minimum value of negative 2. Okay, last, let's go back now and find our y-intercept. Remember, our y-intercept is the value of y, or the value of our function when x is 0. So I want to use x equals 0 to find my y-intercept. So I'm going to put x equals 0 into my function here. I have g of 0 equals 3 times 0 squared minus 6 times 0 plus 1. Notice that we get the term c. So our y-intercept is just 1. And again, this is an ordered pair, 0, 1. You used x as 0, and we got y as 1. So now let's go and let's use all this information to graph our parabola. So let's do our x and our y axis. Here's our y and our x. Okay, there we go. So we're going to graph our vertex, which is at 1, negative 2. So here's our ordered pair for our vertex. We're going to dot in our line of symmetry, our axis of symmetry. It's not actually part of the graph. It is a feature of the graph, and it helps us to be able to find points on the graph. Our y-intercept is the point 0, 1, so we're going to graph our y-intercept. Y-intercept is 1 unit to the left of our axis of symmetry, so another point on our graph is going to be to the other side, 1 unit to the right of the axis of symmetry. We now have a U-shaped graph. We can graph like this. And our minimum value again is the value of our y-coordinate, which is -2. And that's our exploration of the features of quadratic functions. We learned today how to find the axis of symmetry and the vertex of the quadratic functions and how to identify the maximum and minimum values.